The problem we're about to tackle may not appear to have any disjunctions in it, but we're actually going to have to introduce some disjunctions in order to make sense of the absolute value symbols that appear. And that's going to lead us into considering some cases. Here's the problem. Prove that for every real number x, absolute value of 2x minus 6 is greater than x if and only if absolute value of x minus 4 is greater than 2. And in some sense, it's kind of an awful problem. It's a little bit messy. But it's exactly the sort of thing you might need to check. You might end up finding out the solution to some problem are the solutions of this inequality, and it's not really clear which x's satisfy that, right? And you might want to verify that in fact it's these. And this inequality is actually, it's pretty clear what it means, because the absolute value of the difference between two numbers is just the distance between them on a number line. And so the set of all x's satisfying this inequality is, well, if we just draw our 4 here, it's all the numbers x whose distance from 4 is greater than 2. Okay? So if we go 2 to the right and 2 to the left, then x could be anything basically to the right of 6 or to the left of 2. All right. So let's give it a shot. Here's the statement. For all x in R, this inequality is true if and only if that one is. So we have a universal quantifier out here, and we can begin by letting x be an arbitrary real number. So we'll bring that over as a given. And we have this biconditional left as our goal. And to prove biconditional, we want to prove that the left implies the right and the right implies the left. A couple of conditional statements. And so we should take those one at a time. Let's do the left to right direction first. And to prove that conditional, we will do direct proof, bring the antecedent over as a given. And then here's where I have to introduce a disjunction, right? So this inequality, the left-hand side means something different depending on whether 2x minus 6 is greater than or equal to 0 or less than or equal to 0, right? So I want to break into those two cases. In fact, I'll just do less than 0 as my second case. And the reason I'm allowed to just add this as a given is that it's a tautology, right? It's always true. Either 2x minus 6 is greater than or equal to 0, or 2x minus 6 is less than 0. Okay, so we can just add that given in there, and that allows me to split up into a couple cases for those two possibilities. And in each case, I'm trying to prove the same goal. And to get from our givens to our goal, there's a bit of algebra involved. And let me just throw it all up there and maybe talk it through. In case 1, we were assuming that 2x minus 6 was greater than or equal to 0, which means that we can just drop the absolute value sign on the left side of this inequality to arrive at 2x minus 6 greater than x. Okay. And then just cleaning that up a little bit, if we, I guess, subtract x from each side and add 6, we get that x is greater than 6. And I really want to know about x minus 4, so then I subtract 4 from each side to get that x minus 4 is greater than 2. And it's also, therefore, greater than 0. It's positive, and that means that x minus 4 is the same thing as its absolute value, so I can add the absolute value sign back on there to get my goal. Okay, absolute value of x minus 4 greater than 2. Now in case 2, I'm assuming that 2x minus 6 is negative. And so the absolute value of it is actually the negative of it, right? It's making it positive, which is, in order to do that, we need to put a minus sign in front. So we can drop the absolute value signs and replace them by a minus sign instead. And then cleaning that up a bit, while distributing the minus sign, we get to the next line. And then looks like subtracting x and subtracting 6 we get here. And dividing by negative 3, we flip the inequality and we get x is less than 2. Which finally leads us to, if we subtract 4 from both sides, x minus 4 is less than negative 2, which in particular means it's less than 0, it's negative. If we just multiply by on each side here by negative 1, we get negative x minus 4 is greater than 2. And because x minus 4 is negative, this thing is the same thing as absolute value of x minus 4. Okay, so we got our goal once again, at long last, in each case. And then we got to do the other direction. So we or go back up here, and we're proving that the right side implies the left side. And I'm not going to comment on this one in quite as much detail. You can pause the video and check out the details if you like. I'll just say that this time our given is that absolute value x minus 4 is greater than 2. And so once again, we're going to add in a tautology here, a disjunction that says, well, either x minus 4 is greater than or equal to 0, or it's less than 0. Okay. And that gives us our cases. And then, just like last time, there's a bunch of algebra to get to what we want. And in each case, we do get that the absolute value of 2x minus 6 is greater than x. Okay. So let me zoom back a little bit, and let's try and write this down. Okay. So first thing we did was to let x be an arbitrary real number to arrive at that biconditional as our goal. So say let x be an arbitrary real number, and we're going to show that absolute value 2x minus 6 is greater than x. And we should write this out in words: if and only if absolute value x minus 4 is greater than 2. Okay. And now we have the two directions, and we're going to attempt the left to right forwards direction first. So we'll indicate that by putting a left to right arrow in parentheses. And once we got there, we tried direct proof. So we're going to suppose the antecedent is true, and consequent becomes our goal. So we should say, suppose absolute value 2x minus 6 is greater than x. We're going to show that absolute value x minus 4 is greater than 2. Okay. And so that brings us to our cases, which came from this sort of tautology of a disjunction right here. And the first option brought us to case 1. And how are we going to say this? Well, first of all, write case 1. And okay, we're going to suppose that 2x minus 6 is greater than or equal to 0. That's the case that we're in. And we said that, okay, then we can drop the absolute value symbol to get 2x minus 6 greater than x. So say then 2x minus 6 is greater than x, which implies, after some algebra, that x is greater than 6. And follows that x minus 4 is greater than 2. There's a lot of different ways to say this. You just got to string it together somehow. Okay, and since x minus 4 is therefore positive, we can add the absolute value sign back in to get absolute value x minus 4 is greater than 2. Good. And now we've got the second case. So this time we're taking this side of the disjunction to get right here. And we will say, this time suppose 2x minus 6 is less than 0, and then that means that the absolute value of 2x minus 6 is negative 2x minus 6. So we have that this is greater than x, and that implies, after some algebra, that x is less than 2. Okay. It follows that x minus 4 is less than negative 2. And since x minus 4 is therefore negative this time, we get the absolute value x minus 4, which is which is the same thing as what we wrote right here, is greater than 2. Okay, so I'm not writing every single step, but certainly enough for the reader to reconstruct my reasoning. And the important thing is that in either case we got our goal, right? But then we remember, oh, we got to do the other direction too. So I'm not going to write this one out step by step. I will throw it up here, although I need to put my arrow first, it looks like. So we have the backwards arrow, and for this one we are supposing that x minus 4 is greater than 2, and we get this as a goal. Okay, so we'll write that. Suppose absolute value x minus 4 is greater than 2. We show that absolute value 2x minus 6 is greater than x. And here are our cases. Yeah, so take some time to read through how those worked out. And it's pretty much the same idea as what happened for the other direction. All right, so I guess we're done.